You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT Fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In this episode, we will focus on string data in programming, what strings are, how they are used, and what operations can be performed on them. A string is a sequence of characters used to represent text, and it is one of the most common data types found in modern software. From displaying messages to storing names and formatting output, strings appear in nearly every programming environment. This episode will help you understand how strings are defined, compared, and modified using simple operations, all within the scope of the IT Fundamentals Plus exam. This topic is covered in Domain 4 of the IT Fundamentals Plus certification, under Data Types and Operations. Questions may ask you to identify a string, recognize an operation like concatenation or replacement, or choose the correct result from a string-based task. You will not need to write any code or use syntax from a specific programming language. Instead, you'll need to understand what strings are used for and what common string functions look like when described in plain language. A string is defined as a sequence of characters stored as text. It can include letters, numbers, punctuation marks, or even spaces. In most programming languages, strings are enclosed in double quotation marks. For example, quote hello, quote, 1, 2, 3, quote, and quote ITF plus quote are all examples of strings. These values are stored as text, even when the contents appear to be numbers or symbols. Strings are distinct from individual characters. A char, or character, holds only a single symbol and is typically stored using single quotation marks. For example, quote A quote is a char, while quote A B quote is a string because it contains more than one character. This distinction is important in programming and appears frequently on the exam. While both represent text, a string can store full names, sentences, or any group of characters, while a char is limited to just one. One of the most common operations performed on strings is concatenation. This means joining two or more strings together to create a single combined string. The plus sign is the most common operator used for this in many programming languages. For example, if you concatenate quote hello quote and quote world quote, the result is quote hello world quote. Notice that there is no space unless you add one intentionally between the strings. Another basic string operation is checking the length of a string. This involves counting the number of characters it contains. For example, the string quote test quote has a length of 4 because it includes 4 letters. Length is important for validation, formatting, and managing user input. You may need to verify that a password is at least 8 characters long, or ensure that a text field does not exceed a certain size. Changing the case of a string is another common task. You can convert all letters in a string to uppercase or lowercase, which helps standardize text for comparison or display. For example, the string quote hello quote can be transformed into quote hello quote by applying an uppercase function. This is especially useful in cases where you need to compare two strings without being affected by differences in letter case. Searching within a string allows you to check whether a particular word, letter, or symbol appears in the text. This can return a true or false result or the position where the substring is found. For instance, if you search for quote at quote in the string quote data quote, the search would succeed because the substring is present. Search operations are useful for filtering input, parsing commands, or validating content. Replacing part of a string is another powerful operation. This means taking one portion of the string and swapping it with something else. For example, if you replace quote blue quote with quote red quote in the string quote blue car quote, the result would be quote red car quote. This function is commonly used in data cleaning, user interface updates, and customizing output before it is displayed. Slicing, also known as extracting a substring, allows you to pull a specific portion from within a longer string. This is done by specifying start and end positions. For example, in the string "computer," extracting the portion from position 1 to 3 might return "com." Slicing is frequently used to isolate specific information like a file extension, user initials, or date components. String manipulation is valuable because text appears in nearly every aspect of software. Whether you're formatting output, checking user input, or generating custom messages, string operations help ensure that the data appears exactly as needed. These operations are foundational for scripting, report generation, form validation, and more. Because of their usefulness, string manipulation skills are emphasized in many entry-level exams, including IT Fundamentals Plus. Another reason string operations matter is that they are universal across languages. While syntax may change slightly, the concepts of concatenation, searching, replacing, and slicing are found in almost every language used for programming or scripting. This means that once you understand the concept, you can apply it to many environments. The IT Fundamentals Plus exam ensures you can recognize these actions in any context. Finally, many common problems in programming involve strings. Whether it's handling names, formatting phone numbers, or converting input into usable output, manipulating text is an essential task. Learning to identify and understand string operations gives you a powerful toolset for solving everyday programming challenges. On the exam, focus on the operation being described and choose the response that best matches the result. One essential aspect of working with strings is formatting text for output. This means combining variables, labels, or fixed phrases into a single, human-readable line. For example, if you want to display a score, you might format it as "Your score is 85." Formatting often includes the use of new lines, tabs, and spacing to organize output neatly, especially when displaying reports or structured data. Although you won't be required to write code on the IT Fundamentals Plus exam, you should understand that formatting makes program output easier to read. Escape characters are another important string-related concept. These are special symbols used within strings to represent formatting commands or to include characters that would otherwise end the string. For instance, \n represents a new line, and a quotation mark can be written as \quote inside a string. Escape characters allow you to include punctuation, line breaks, and tabs in text while preserving the structure of the string. These details may appear in exam questions that describe string behavior or formatting outcomes. Strings are also heavily involved in input and output operations. When users enter information into a program, it is usually captured as a string by default, even if it looks like a number. This input must often be converted to other data types before being used in calculations. On the output side, numbers or booleans may be converted into strings so they can be displayed. Understanding this conversion process helps explain why string formatting is so common in interactive programs and exam scenarios. Comparing strings is another fundamental operation. It involves checking whether two strings contain the same characters in the same order. Comparisons are often case-sensitive, meaning "hello," and "hello," would not be considered equal unless both are changed to the same case. String comparisons are used in if statements, search filters, and data validation. On the exam, you may be asked what happens when two strings are compared and differ only by letter case. Strings are everywhere in real-world information systems. They represent usernames, email addresses, messages, locations, passwords, and product descriptions. They appear in database records, log files, interface labels, and error messages. Because they are such a versatile and widely used data type, nearly every application depends on string operations in some form. Recognizing this importance helps put exam questions about strings into practical context. Exam questions involving strings may come in several formats. One type may ask you to identify an operation, such as concatenation or replacement, based on a brief description. Another may show an input and ask what the output would be after applying a certain operation. Some questions may describe a string manipulation scenario and ask which operation is being used, such as converting text to lowercase or extracting part of a message. There are key terms you should memorize to prepare for these questions. These include concatenate, substring, length, and replace. You should also recognize uppercase, lowercase, search, and format. Knowing what each term means and being able to match it to a common task will help you work through exam questions quickly and accurately. You won't need to know exact syntax, but you must know the purpose of each operation. The exam will not test your ability to write code, memorize syntax, or use programming methods. You won't be asked to create a string, loop through characters, or use specific language tools like dot replace or bracket indexing. The focus is entirely on recognition. When given a task like, quote, change hello to lowercase quote, you should be able to select the operation that performs this task without worrying about how it's implemented. Another useful concept is how strings relate to other data types. Although a string may include numbers like, quote, 1, 2, 3, quote, those numbers are treated as text. A string containing digits is not the same as a numeric value. If you want to perform arithmetic, the string must first be converted to a number. Likewise, when you want to display a number, it may need to be converted into a string. These ideas may be described in scenario-based questions. Strings often play a supporting role when working with user interfaces, reports, and messages. For example, confirmation messages like, quote, your password has been changed, quote, are created using strings. When building forms or reports, strings are used to label fields and display dynamic values. These examples show how string operations contribute to software usability and clarity, making programs easier to understand and use. You may also encounter questions that describe operations like slicing or searching. A slicing operation selects a portion of a string, such as extracting the word, quote, month, quote, from, quote, monthly report, quote. A search operation checks if a string contains another string, like checking if, quote, data, quote, appears inside, quote, database, quote. Both are simple but powerful tools for analyzing and controlling text in a program. It's also helpful to remember that string operations support logic and control. For example, a script may check whether a user's input matches a certain command or if a particular keyword is present in a message. These logical checks often rely on string comparisons, case formatting, or substring matching. Knowing how these operations work helps you understand how programs make decisions based on text data. To conclude this episode, remember that strings are a flexible and essential part of programming. They are used to store and manage text, and they support a wide range of operations, including joining, searching, replacing, slicing, formatting, and comparing. The IT Fundamentals Plus exam tests your ability to recognize these actions, understand what they do, and identify their use in common scenarios. Mastering string terminology and behavior will strengthen your skills in Domain 4 and prepare you for real-world programming tasks. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.